All right, this is problem number 8 on the 1.4 topic questions. You should have it in front of you, and you could recreate everything here. Our goal is to figure out, given this system, we want to find the speed of the stone relative to the train. Train's going this way, stone's being thrown up and to the left or away from the train. We're told that the train's going 18 meters per second, and I'm putting a positive there because as a vector, I'm going to say positives to the right and up is to the right. Why up? Because I see Vs is going up. So I'm going to kind of anticipating that. And this is a vector, meaning it's positive 18 meters per second. For Vs, they tell us that that's just 10 meters per second. It's a speed, so you could think of it mathematically as an absolute value. It's the length of that vector is 10. The angle is 45 degrees up that way. Okay, find the speed of the stone relative to the train. Speed of stone relative to the train. Speed is the absolute value of the velocity. Which velocity? It's the velocity of the stone relative to the train. VST. That's what I'm looking for. The magnitude of that vector, right? Because speed is the magnitude of a velocity. Okay, how do we solve this? Well, relative motion. Let's go with our relative motion equation, which is VA, whoops, let me switch markers, starting to wear them out. We're going to go VA relative to the ground is equal to VAB plus VB relative to the ground. These are vectors, which we'll have to use vector math because I've got something moving in two directions at once. In other words, Vs has components in the x and y. So I'm going to reinforce the idea that you got to think vector math. Okay, so our equation has A, B, and G. Luckily, the language suggests that we're looking for the magnitude, speed, of the velocity vector, magnitude of the velocity vector, which is speed, stone relative to the train. So they're giving us ST. What's all this then? Well, the velocity of the train relative to the observer is on the ground. So this is really the velocity of the train relative to the ground. This is the velocity of they told us relative to the observer, so this is the velocity of stone relative to the ground. What are you trying to find? We're trying to find VST. So how do we take our T's, our S's, and our G's and map them to A, B's, and G's? Well, I've got ST there, I've got AB here. This has no common reference, right? It's not relative to the ground or the observer in this case. So this guy must be that. So I'm going to rewrite this equation as velocity ST. Well, if A is S and B is T, this one's got to be the velocity of TG. And this has to be the velocity of what? What's my A? S. SG. So there's the equation I can use. Which one am I trying to find? I'm trying to find VST. So I'm going to rearrange it just to isolate for ST. That might help my brain. So VST is actually equal to VSG minus, because bring that to the other side, minus VTG. All right, so now I just got to find the magnitude of this vector. How am I going to do that? Because these are vectors. Well, we go vector math, which means components. Right, so I'm going to look at the x direction and look at the y direction. And I'm going to rewrite this equation in terms of x's and y's. This says my velocity st in the x direction just has to be the velocity of sg in the x direction minus the velocity of tg in the x direction. In the y's, I've got the velocity of st in the y direction has to equal the velocity of sg in the y direction minus the velocity of tg in the y direction. This is all set up. Okay, nothing specific to this problem yet other than mapping our A, B, G subscripts to STG. This is just this is that equation broken up as x and y components. Okay, let's keep going. First, we gotta even though we broke them up, we still have to follow that reference frame, or what positive means, right? Positive means to the right, up is positive. So let me start with the y. Now, it doesn't matter which order, but I notice that vt only goes in the x direction. So it has no y component. So this one simplifies pretty quickly. VST in the y direction is just going to be VSG in the y direction minus 0. So those two are identical. I'm going to stay here and finish this one off. So what does this say? It says the velocity of, or the speed of the stone, if you want to think about it that way, in the y direction is just the same as the speed of the stone relative to the ground in the y direction. So now comes vector math. And hopefully you can do this pretty quickly. But if you look at this vector, I'll draw a little side drawing here. If VSG is at an angle theta that way, then VSX is going to be VS cosine theta, and VY is going to be what? VS sine theta. So if you need to, pause here, make sure you understand why the sines and cosines are the way they are. Okay, here's theta. Okay, but if you break that up properly, then you've got VST in the y direction is a positive, because it's going up, positive VS times sine theta. So VS is just 10 sine 45. If you want to make it a vector, right, you could say the y component of the VST vector is it's that, but remember that that's an important implied positive. That's the direction, up. Over here, what's VSTX? VSGX, that's this guy, but it's to the left. So that's going to be minus VS, which is 10 cosine 45, minus the velocity of TG in the x direction, which is just VT, right? Because it's only going to the right anyway. So that's going to be minus 18, which says that the velocity of the stone relative to the train is negative, right? It's got to be negative. Does that make sense? Well, yeah. I mean, regardless of your reference or your which velocity, what your taking the velocity relative to what, right? Whichever, in other words, whichever combination of subscripts. This reference frame is true for all three of them. So we don't have multiple definitions of up and down and left and right. So the velocity of the stone relative to the train is in the negative direction. Well, that makes sense. And it looks like it's going to be going faster than 18 to the left, because I've got a negative here, negative 18 here. I'm going to have a number bigger than 18 to the left. Well, that makes sense, because relative to the train, the stone is being fired really fast backwards, right? Because on the one hand, to the ground, I'm going 10 cosine 45 this way, but at the same time, I'm moving away from it. So it looks like I'm going faster to the left, okay? Anyway, that's the math. I won't do the calculator work, but this is a velocity, right? That's a vector. It's negative, whatever this turns out to be. So how do you get the actual speed? The actual speed, VST, the magnitude of that vector is going to be the square root of the magnitude of VST x squared plus the magnitude of VST y squared. So once you have numbers for these, you just square them, add them up. It's Pythagorean theorem, take the square root, and that's how fast the stone is moving relative to the train, the speed.